Thank you. Hey, today is 5-4 slope-intercept form, and I know many of you, just from conversations we've had in class, many of you already know what slope-intercept form is, but if you don't, maybe try within your groups to discuss and see who knows it and who doesn't know it, and what the parts of the equation are. So give you about a minute there to talk about that and get your learning goal down. Okay? Please. Okay, slope-intercept form. What is it? Who's got it? Oh, come on. Brendan, what do you think?
Maybe where the slope crosses the y-intercept.
Okay.
Crosses y.
So you're thinking like slope and intercept, so you have to do something with the slope and intercept.
Yeah, like when the slope is going up, it hits the y-intercept.
Good. All right. That's a good idea. Anyone ever hear of the form y equals, yeah? Keep going. mx plus b. Who's heard of that? Good. That is slope-intercept form. And as Brendan pointed out, it has to do with your y-intercept, which is your b term. So that whole thing. So if it's positive, it's positive. If it's negative, it's negative. This is where it crosses. Your graph crosses the y-axis. Oops. Got to spell graph right, though. All right. So you should write this stuff down, man. Graph crosses the y-axis. Okay. That's called your y-intercept. So that's where the intercept part of the slope-intercept form comes in. All right. I think it's better if I just turn that off. I don't know if it matters to you guys. Does it change the look of it? No? Okay. How about this? What's M stand for? Cool. It's not the x-intercept. No, good guess. TT? Yeah, M's your slope. Okay, and we like to think of M in this case as our rise over run. Our slope, which is the same thing as rise over run. Okay, so what slope-intercept form does is it helps us to quickly, easily, efficiently graph your equations. It gives you a starting point, your y-intercept. So some students will even call this their starting point. You'll hear, like if you're talking with your friends on it, they go, this is my starting point. Okay, that's what they're talking about, the y-intercept. And once they plot that, then they use their slope to find another point. And really, that's what we're doing today. Okay? All right. How many are with me so far? All right. Let's try some of these. Let's look at our assignment. And you can notate you can add things to your notes as we go, but your assignment, your graphs will look a little different than mine. Okay? So in fact, let me use your grids. That would make it a little more, give us a little more continuity. So number one, let's do number one together. Y equals 2x. Okay, I want you to go ahead and identify with your neighbor what the slope and y-intercept is of that equation. Okay, what is our slope? Marie? Yeah, well, our slope is 2. Yep, that's your m. Okay, your m is 2. What's your b? TT? 0. We're not adding anything. Now, this is our y-intercept. Okay, our b. Okay, that means our starting point is what, Toki? 0. Yeah, we start at 0. Okay, we're going to start right here. In this case, our slope is 2. Now, 2 meaning slope in fraction form is actually what? Annalise? Yeah, 2 over 1. Okay, so we put a 1 under that. So we rise 2, and we run 1. We rise 2, and we run 1. Remember, I like to circle my starting point. But there we go. And once you can see the trend, I want you to keep going. I want you to go down now in this way. You can see the trend in the line. So just keep that slope on going and fill the whole grid up. Okay. Use a straight edge, draw a line, and since it goes on forever, we put our arrows on the end. Y equals 2x. So if it doesn't have a y-intercept, we don't see a y-intercept, it's always 0. If it doesn't have a number under the slope, then it's 1. We like fractions with slopes because that tells us a rise and run. If it doesn't have that number, then it's a 1 under it. Bless you. Any questions on that? Like everyone to try number, go ahead and skip number 2 for a minute. Let's go on to number 3. Let's try number 3. On your own. All right. Well, this one's a bit different in the sense that our grids are smaller, right? So we're going to go to y-intercept of 2, and if we don't actually put any numbers by our y-axis, then that means we're going up by 1 every time. Unless if you change your scale, like if you said, okay, 2, 4, 6, 8, 10, if you wanted to say I'm going up by 2s, you'd have to put a 10 up there and say, okay, that means I'm going up by 2s. Now I'm going to keep going up by 1s, but the problem is we've always talked about from our starting point, we've always talked about rising and then running to the right. Well, we don't have room to go up 4. If we did, it would kind of be like right about there. And you can kind of see the trend of that line. It's a positive slope. But I do have room to go down. I could go 1, 2, 3, 4. But in this case, which way do I go? Left, because it's got to be a positive slope. 1, 2, 3, 4, and there. So notice when I'm done, I should always check to make sure my line has the correct slope to it. Is it positive or negative? In this case, since this number is positive, that means our line has to be rising from left to right, or a positive slope of our line. Okay? So a thing that you may even put on top of your paper if you had forgotten that, remember your positive slope rises from left to right. A negative slope, like on number 2, number 2 is a negative slope. That means when you're done, this picture should look like that. Sometimes I see students on quizzes and tests, they even before they graph it, they do that. I see that just on the side right next to the equation. No, that's their reminder that this line, before I even graph it, better be falling from left to right. Okay? It's a good reminder. All right, any questions on number 3? Okay, give number 2 a shot. I'll be walking around. Make sure you're asking if you need help. Okay, what's our y-intercept?
3.
Starting point is, Ayla, what do you got? 3, yeah, 3. So 1, 2, 3. Make sure you're on the y-axis, right? So we circle that. And then the negative tells us negative 2 means down 2 over 1. Down 2 over 1. Or if you went up 2, you could go to the left 1. So the negative sign is kind of like a floating negative sign. It could, in this case, it says negative 2x, but like if we were to say, well, actually, before we do that, any questions on number 2? Okay, don't make the mistake of accidentally putting your y-intercept on the x-axis. That happens. And then sometimes students don't do rise over run, they do run over rise. They accidentally flip that. Okay. Hey, let's take a look at, say, number 5. All right. Number 5, notice it says negative 7/3 x. So our starting point is at 2, right, our y-intercept. Okay. The negative sign is kind of a floating negative sign. So it could go up here with the 7. It could go down here with the 3. It can't go to both places, otherwise it's negative divided by negative, which is positive. So it has to go up or down. Usually I move it up. So that would mean if I was to rewrite this, I kind of scribble out the negative right there and I put it up here, which now I have go down 7 and over 3, which means I go 1, 2, 3, 4, 5, 6, 7 and over 1, 2, 3. Okay, now sometimes you just might not have room to do that. Maybe your y-intercept was down here. In that case, you would maybe think of it by putting your negative sign over here, which means now you go up 7. 1, 2, 3, 4, 5, 6, 7. Let's just assume we can. But then rather going to the right, you go to the left. You go back 3 this way, which would be about there. And so you can kind of see my line still would hit that, right? If I had my straight edge, okay, that would be where my line is. I usually think of my negative sign up with the top. So I go down, and I always try to move to the right if I can. However, today on this, if you don't have enough grid space, you're going to have to go up and to the left. Okay, I think most of the time you're going to have enough grid space. But. Okay, any questions on it? All right. I'm going to give you about 4 minutes to work there. For those of you that are ahead of the game, if you look at example 2 real quick, what do you have to do in order to graph this first?
Get the y by itself.
Yeah, get the y by itself. Rewrite it in slope-intercept form, and then graph. Okay, so for those of you that are really cranking through example 1 up here, and you're ready to move on to example 2, you could try. I would just start on each problem trying to get the y by itself before I graph anything. Okay? We'll start talking about that as a class here in about 3 minutes or so. Okay, any questions on example 1? All right, let's move on to example 2. Example 2 says to rewrite each in slope-intercept form. So, for instance, on number 13, if we're taking a look at that one, if I want to get y by itself, I've got to move that 4. How do I move it when they're adding 4? Bobby?
Subtract it.
Yeah, we just subtract 4. Now, when I subtract 4, can I take 3x and subtract 4 from the 3? No, they're unlike terms, right? One has an x, one doesn't. So we just write it. Positive 4, negative 4 is 0, so we just have y. And then we have our 3x, and we can't subtract the 4 from them, so we just put 3x minus 4. But that's slope-intercept form. So the y-intercept in that case, we have a negative 4. And we should be able to graph it from there, right? Rise 3 and run 1. And I know that a lot of you were getting to that point, but there we go. Any questions on it? I want to try one more together on that. If you'll take a look at number 17, it's actually on the next page. Mackenzie, do you have a question? Yeah, so what did you get on number 14? What's the question there? Yeah, so when you move 14, yep, you're going to add 5x. That negative goes with that. So yeah, your slope then is going to be a positive slope. You have a positive 5x and you have a minus 4. Yeah. Good question. All right. Let's take a look at 17. 17, I want everyone to turn number 17 into slope-intercept form. Okay? Go ahead and work with your partner on it. Let me discuss it a bit. All right. Walking around, I saw a lot of you had done it right. You'd moved that 4/3 x over. I noticed most of you had subtracted it. Some of you didn't show the subtraction sign, but you made it negative when you brought it over there, and some accidentally had a positive 4/3 x over here. So just make sure that's a negative 4/3 x because they're adding. You got to do the opposite, which is subtract, and then you've got the positive 1 in the back. Okay? So now remember, I always like to think of the negative sign as being on top, but it could be anywhere. It could be on the bottom also. So when I go to graph it, I've got my 1, and from that I either can go up 4 and 3 to the left, so backwards 3, or I could go down 4, which is what I usually do, and then to the right 3. Either way works out. I start here, go up 1, 2, 3, 4, and backwards 3, or down 4 and forwards 3. Okay, I've got my cool line, my Cool arrows. There, we got it. Any questions there? Doing a good job. Okay. I'll give you guys about 5 minutes to work on that section. For those of you that are done with that section, when you get to example 3, if you want a head start there, write the equation of a line given the slope and y-intercept. Remember, what is slope-intercept form?
Y equals mx plus b.
Yeah, it's y equals mx plus b. And the two things you need in order to write an equation of a line are m and b. It's kind of nice that they give you m and b there. So all you have to do is write the equation. So some of you will pick up that pretty quick. We'll go through that together here in about 4 minutes or so. Okay. So hey, looking at example 3, I really want to focus on just this statement real quick, something to add to your notes. And it may seem pretty obvious right now, but as we progress through the different relationships and then we try to remember at the end of the year, it's something to write down. Okay? We know the equation of a line, writing the equation of a line given m and b. In order to write an equation of a line in slope-intercept form, in this form, we need to know two things. Okay? The things that always stay are x and y. Okay, the two things we need to know are those. We need to know both m and b. Okay, so you can kind of think of those as like empty seats. All right? Y equals something x plus or minus something else. Okay? This back piece is kind of an empty seat as well. All right, so when we're looking at example number 3, in fact, number 25 there gives you, says m equals 3 and b equals 2. Well, these are just replacing these letters here. So if m's 3, our 3 gets plugged in there. If b's 2, our 2 gets plugged in there. So there's our equation. Notice y and x stay because when we're graphing these, we're graphing it on a xy axis. Today we're not asked to graph this after we write it, we're just asked to write it. Remember, we want to be able to eventually be able to graph that. That's why we have to keep the x and y in there. The m and b are the two things that change. Okay, so in this case, we've got to throw those in there. All right, seems pretty easy, but that's kind of leading us into our next step tomorrow or on Wednesday. Okay. Any questions there? Tell your neighbor how that would change if this was a negative. How would our equation change? Okay, volunteer. How does it change when that's a negative? Annalise? Yeah, rather than having an addition sign here, that wouldn't be addition, it would be subtraction. So it would be y equals 3x minus 2. It's only difference. Okay, if it was a negative. All right. So you guys are working on example 3 there. Okay, if you haven't finished example 1 or 2, just skip to 3 and work on that for a few minutes. And we'll go into our last step for today. And then some of you will be getting close to being finished. And you'll have the rest of the time to work. Let's talk. Well, any questions on that part? Okay, let's talk about this last piece here. Okay, if we're taking a look at its example. This last part here, example 3, but I'm going to put up a blown up version of number 42 here. Okay, number 42 says find the slope and y-intercept of each line and then write the equation. So if you haven't made it to 42 yet, go ahead and pause and where you're at and start on that. I want you to, using the picture, find the slope and y-intercept. Come on, someone new? Trinity? 4? Yeah, so if we find two places where it crosses the graph perfectly on the grid, it crosses there and it crosses there. So our slope from this point to this point, if we rise 1, 2, 3, 4, and we run 1. So the slope is rise 4, run 1. It's going up from left to right, so it's a positive slope. What's our y-intercept? Marie? Yeah, y-intercept where it crosses the y-axis is -4. Be careful not to put 1. What is 1 called? Tyler?
Yes.
Yeah, that's our x-intercept. Okay, we want the y-intercept. So notice our slope is 4, our b, our y-intercept is -4. If we use our equation, y equals mx plus b, and we put in these important pieces, there's m and there's b, we get y equals 4x and -4. There are 2 special cases, okay? Any questions on that real quick? 2 special cases. One special case has a grid that looks like this, with maybe a line that would say be like that. Let's put -2 there. And another special case that looks like this, and say a line that does that. Let's say that, let's put this one at 4. Right there. Okay? In these lines where you have a horizontal or a vertical, okay, first on this first one we can kind of think of it the same way. Our m, what's our m? What's our b? Go ahead and tell your neighbor what the m and b are on that one. What do you think it is? All right. Chelsea, what do you think m is?
Oh, yeah, sure.
Do you rise in this one? Huh? So if I was like to go from this point to say that point, am I going up at all or down? No? Okay, so I'm not rising. Am I running? Yeah, I'm continually running, but we could have a lot of run there, so it would be 0 over a number, which in this case, what's 0 divided by a number? 0. Our slope's 0. It's a flat line. It's 0. What's our b? What's our y-intercept? Everyone. What was that? That's a gang sign, dude. -2? Okay. All right. -2. So it only crosses the y-axis. It crosses it at -2. Y equals -2. Has 0. You could write it as y equals 0x minus 2, but that's still y equals -2. Okay? Tell your neighbor what axis this one crosses. Okay? Cole, which axis? This crosses the x-axis. So when it only crosses the x-axis, it's an x equals equation. What does x equal? Where's it cross? Everyone? 4. Yeah, it crosses at 4. That's our equation. There's no y. It doesn't cross y. So if it only crosses the x-axis, it's an x equals. There's no y. If it only crosses the y-axis, it's a y equals. There's no x. In order for there to be both an x and a y, it has to cross what? Yeah, it has to cross both x and y. Okay, that's a good rule of thumb to get into. Like, if you guys haven't realized that about your graphs, in order to have an x and a y, it has to cross both x and y. In order for it to have if it just crosses y, it just is a y equals. If it only crosses x, it's only an x equals. If it crosses both, then you have to have both variables. Pretty cool. What do you see, Jaden? Something funny? Yeah? What? Is it okay for me to know? Huh? Yeah, what is it? Dude, that's like having a good joke and not sharing. Yeah. All right. Let me know if you have questions. I'll be walking around.